All right, so our next lesson is going to be trigonometry. So we're going to be covering trigonometric ratio. So trigonometry is a branch of mathematics that deals with the relationships between the sides and the angles of triangles. So one of the definitions of the word opposite is a position on the other side of something, and the meaning of the word adjacent is to be next to something. So we're going to be using these a lot. Opposite, adjacent, and then also hypotenuse, okay, which I hope you guys are pretty familiar with. So here the hypotenuse, now the hypotenuse is never going to change depending on the triangle. The opposite will change depending on which angle you're talking about, but the hypotenuse will always be the side across our 90-degree angle, okay? So directly across from it, that's always your hypotenuse. So across from this angle here, this is our hypotenuse. We also know our hypotenuse as our longest side, okay? So now, if we look here, they give us angle A. So here's angle A. So opposite angle A would be this side over here. Okay, so this is considered opposite angle A. So we're going to put a letter O here. I like to use a cursive O just because we get it confused with the zero. So that's opposite. You know what, let me put OPP for opposite, because we're going to use that little theta symbol. So OPP for opposite. And then the side that is touching the angle, so we have two sides that touch the angle. We have this side and this side, okay? Now, this side we know is the hypotenuse, so this side is the adjacent side. EDJ. Okay, that's adjacent. I didn't put HYP for hypotenuse. Hypotenuse. Okay, so here we have hypotenuse again. Now this time they signify angle B. Okay, so this is angle B. Now opposite angle B would be this side over here. That's my opposite, OPP for opposite. And then this side over here is my adjacent side. Okay, so my adjacent side would always be touching an angle, so ADJ. And you actually have two sides that touch the angle. You have the hypotenuse and the other side, okay? Of course, we already identified the hypotenuse, so then this side must be the adjacent side. All right, so then we got to do this one more time. So if we look here, we always start off, I think the easiest is identifying the hypotenuse. You guys are already really good at identifying the hypotenuse. So I'm going to go ahead and identify the hypotenuse here. So HYP, HYP. Okay. Now, if they give us angle A here, then we have to look directly across from it, and that is our opposite side. Okay. In this case, they want us to go based off of angle B. They changed the angle on us. So since they changed the angle on us, this side is considered the opposite. Okay. And then, whoops, adjacent side, starting with angle A. Since these two sides make up angle A, this one's considered my hypotenuse, so then this one has to be my adjacent side. And then the same with angle B here. We have two sides that make angle B. One side is a hypotenuse, the other side is the adjacent side. And that's it. Okay, so one more time. Okay, we have our 90-degree angle here and here. So then these two are, whoop, that went crooked. These two are considered my hypotenuse. Hypotenuse, HYP. And then let's go ahead and look at angle A first. So here's angle A. Directly across from it is considered our opposite. So this is OPP. Now, if we had here angle B, directly across from angle B would be our opposite. Opposite. And then we go ahead and identify our adjacent side. So the other side that makes up angle A is going to be our adjacent side. Same here with angle B, this is considered our adjacent side. Okay, so now that we know how to identify our opposite, our adjacent, and our hypotenuse, we're going to need this to set up our trigonometric ratios. So it's a ratio that relates one of the acute angles with any two sides of the triangle. So trigonometric ratio. So I know you guys have seen these buttons on your calculator. Maybe you weren't sure exactly what they were. But we have our sine ratio, we have our cosine ratio, and we have our tangent ratio. Okay, so our sine ratio is the opposite side divided by our hypotenuse. Okay, the cosine ratio is identified by the adjacent side divided by our hypotenuse. And our tangent ratio is identified by the opposite over adjacent. Okay, so you will be required to memorize this. There's different ways to memorize this or to remember this. Since this is a sine ratio and it's the opposite over hypotenuse, we call this SO. Okay, S stands for sine, O stands for opposite, H stands for hypotenuse, and then our cosine ratio is the adjacent over the hypotenuse. And then the tangent ratio is opposite over adjacent. So we refer this to as Sohcahtoa. There is some little abbreviations. There's some old hippie caught another hippie, tripping acid. That's another way to remember it. Whatever you feel is most appropriate, you can go ahead and do that. So here, there you go. They put it as Sohcahtoa. Is a helpful mnemonic pattern of letters for remembering the trigonometric ratios. So on here it says, on each triangle, write the indicated ratio as a fraction in simplest form. So sine, just in case you don't remember, and it tells us here sine equals opposite over hypotenuse. So I'm going to go ahead and write this as opposite over hypotenuse. And so since they said sine of A, let's go ahead and look at angle A. So here's angle A. So opposite angle A is 21 over, and then the hypotenuse, well, the hypotenuse needs to be the side across the 90-degree angle, which is a 35. Okay, now we have cosine. So cosine equals adjacent over hypotenuse. Okay, so here we're going to do the adjacent side divided by the hypotenuse. All right, so cosine of angle C, they tell you here cosine of angle C. So here's angle C. We're looking for the adjacent side and the hypotenuse. So the side across the 90-degree angle is considered the hypotenuse. So the 34 is going to go on the bottom because the hypotenuse is 34. And then the adjacent side, remember the adjacent side is the other side that makes up this angle C. So it's going to be the 16. And then next we have tangent of angle A. So tangent equals opposite over adjacent. So O over A. Okay, so they want us to do tangent of angle A. So here's angle A. Now the opposite is going to be this 48. I'm going to go ahead and put an OPP here. So the opposite is 48. So it's going to be 48 over, and then our adjacent sides, remember we have two sides that make up A. If this is a hypotenuse, then that means that this one's adjacent. So the 14 is adjacent. Okay. So there's one thing I didn't do. I just wanted to set up the ratios real quick. When you do give the ratios 21 over 35, sometimes they're going to ask you in decimals. Sometimes they're going to ask you, in this case, they ask in simplest form, a fraction in simplest form. So we're going to have to reduce 21 over 35 is going to give us 3 over 5. 16 over 34 is going to give us, let me see, 8 over 17. And then 48 over 14, I believe, let me see, 24 over 7. And that's it. Okay, so here it says, use the right triangle to complete the chart below. Write the ratios in fractions in simplest form. Sorry, this little box here, it's supposed to be an angle, but I guess it didn't read the file correctly, so I just left it blank. Blank. Okay. So here it says length of the leg opposite from angle A. So if we look here on angle A, the opposite is going to be 9. It says length of the leg of adjacent to angle A. Okay. So the adjacent side to angle A is going to be the 12. So this is my adjacent. ADJ. And that's going to be 12. And then the length of the hypotenuse, remember the hypotenuse is the longest side, which is 15. So then we're going to go ahead and write the trig ratio. So we do need to remember Sohcahtoa. So Sohcahtoa. All right. So here, sine is equal to opposite over hypotenuse. Okay, so we already identified that the opposite was 9 and the hypotenuse was 15. Whoops, 15. And then I'm going to go ahead and simplify this. So 9 over 15 is going to give me 3 over 5. Okay, now the next one, cosine of 8. So here, we have 12 is my adjacent side over my hypotenuse, which is 15. And if we reduce that, it is going to give me 4 over 5. And last is tangent, which is opposite over adjacent. We said the opposite was 9, and the adjacent was 15. No, I'm sorry, 12, not 15. So then 9 over 12 is going to reduce to 3 over 4. All right. So now, what happens when they do, or they switch angles? So we're going based off of angle A. Now they want us to go based off of angle B. So the length of the leg opposite angle B. Well, here's angle B. So now this is no longer opposite. So I'm going to go ahead and erase these. It is now, this 12 is my opposite. Opposite. So 12. Okay. And then the 9 ends up becoming our adjacent. Okay, now the hypotenuse does not change because it's our longest side. It's not going to change to get longer, bigger, smaller. I mean, it's not going to get any smaller. So this will always be our hypotenuse. Okay, that doesn't change. Just the opposite and the adjacent do change depending on which angle you're looking at. In this case, we're looking at angle B. We said the length of the adjacent, which is B, is going to be 9. And then the length of the hypotenuse, like I said, it doesn't change. It's going to be 15. And then we're going to do our Sohcahtoa, or our some old hippie caught another hippie tripping on acid. Okay, so our sine function is a ratio of our opposite over hypotenuse. So our opposite here is 12 and our hypotenuse is 15. Now 12 over 15, if we divide or we simplify, this is going to give us 4 over 5. Okay, now cosine is our adjacent, which is 9 divided by our hypotenuse, which is 15. So 9 over 15 is going to reduce to 3 over 5. 3 over 5. Okay, and then tangent of B. So our tangent of angle B is opposite over adjacent. So our opposite side we said was 12 over our adjacent, which is 9, and 12 over 9 is going to reduce to 3 over 4. Okay, so that's how you set up your trig ratios. We're going to go ahead and do this one more time, but this time they want us to round three decimal places. Okay, so we're going to do everything for sine of D. Now we do need to remember some old hippie caught another hippie tripping on acid. Okay, Sohcahtoa. So first we're going to go based off of sine of D, angle D. Okay, so here's my angle D. I'm going to go ahead and label real quick. So if this is D, that makes this my opposite. Okay, this is my 90-degree angle, so that makes this my hypotenuse. And then the other side is my adjacent side, so A, B, J. Okay, so sine is opposite over hypotenuse. So my opposite happens to be 24. My hypotenuse happens to be 30. They want us to write this as a decimal, so 24 divided by 30 is going to give me 0.8. 0.8. Sorry, I'm running out of space. All right, cosine is adjacent over hypotenuse. So my adjacent side is 18 over my hypotenuse is going to be, 18 over 30. So I'm going to write 18 over 30. They do want us to round to 3 decimal places if possible. So here 18 over 30 is going to be 0.6. And last, tangent is going to be our opposite over adjacent. So our opposite is 24, our adjacent is 18. So I read as 24 divided by 18, which gives us, let me punch that in my calculator. That gives us 1.3333333. So we're rounding 3 decimal places. So that's where it's done. Okay. Now they want us to find the sine of angle E. So I'm going to have to erase my opposite and my adjacent. Remember, your hypotenuse stays the same. My hypotenuse will always be 30. But since we're going based off of angle E now, that means that this one is now my opposite, and this one is now my adjacent. Okay, we're still doing Sohcahtoa. Sohcahtoa. So sine is opposite, which is 18, over adjacent, which is 24. So 18 over 24 gives us 0.75. Cosine of angle E is going to be adjacent over hypotenuse. So my adjacent this time is 24 over, why did I do that? 18 over 24. I'm such a dork. That's supposed to be my tangent. Sorry. So 24 over 30. Let me do that real quick. 24 over 30 is 0.8. Sorry, I don't know why I put this over 24. It should have been over 30. 30. Oh, my pen's not working. 18 over 30 gives us 0.6. And then tangent of E is going to be opposite, which is 18 over adjacent, which is 24. So 18 over 24 we said was 0.75. And that's it. Thank you guys. We'll see you next time. Bye.